All right, welcome everybody to this ABB Robotics webinar. My name is Arvid Wibom, and I'll be the host of today's webinar, and I'm really happy that all of you could join us. So the topic of today's session is how to use vision with collaborative robots. And here to present this is the Global Product Manager for Collaborative Robots, Andy Chung. And she's also joined by Katja Butterweck, who is a Global Application Specialist. So I will hand over to them shortly for the presentation. But before I do, I'd just like to say that if you want to interact with us during this webinar, you could use the chat. And also, if you have any audio issues or any concerns, please just use the chat and chat with me, and I will try to help you to my best abilities. Also, as we go along in the presentation, there will be a question as in the form of a poll that will pop up. So when you see the poll, please take time to answer it. It's a very simple question, really. So with that said, I would like to hand over to Andy. Most welcome. The floor is yours.
Hi, Arvid. Hi, everyone. Arvid, can you hear me and see me okay?
Yeah, loud and clear. Please go ahead.
Okay, great. Then let's get started. So hi and welcome to the second of ABB Robotics webinar series on collaborative robots. My name is Andy Zhang, and I am the Global Product Manager for Collaborative Robots. Together with my colleague Katja, who is a very talented and experienced cobot and robot application specialist, we want to give you some hands-on information on how you can use vision to enhance your robotic applications. So I will start with an introduction of collaborative robots, their benefits, and a little about ABB's Yumi robot. And then Katja will give you detailed explanation on how to create applications using vision. So first, let me give you an overview on some of the main benefits of cobots. Let's see if we can switch to the first slide, please. Katja, can you switch to the first slide, please? Maybe the presentation is stuck. So I think we might be having some technical issues with the presentation, or maybe it's just me.
No, it's the same for me. I just see the first slide.
Okay.
I don't know, Katja, perhaps you could share and unshare your screen if you're still with us. You seem to be online. Okay.
Welcome.
I think she is struggling with her computer.
Yeah, I'll try to see if I can share it from my side.
Now I can see it. Now it's the right slide. Perfect. So let's talk about collaborative robot and why people want them. What are the main benefits? So first that comes to mind is, of course, safety, that we want to enable fenceless installation of robots, of course, in a safe way. And where does the safety come from? It comes from limited power and force, either from limited power and force, which comes from safe design of the robot, such as rounded edges, padding, and very important is low effective moving mass, so that you can make safe collision between human and robot. It can also come from sensors inside the robot, which detect the collision and stop the robot after the collision. And there's also a type called safety speed and position monitoring. And this means that there is a minimum distance between a moving robot and a human, even when it's installed without fences, to prevent any dangerous collisions happening. And the second point is ease of use. So typically collaborative robots are smaller, so they're easier to install and calibrate. You can move the robot by your hand with what we call a lead-through function. So which you can see in the picture here that Katja is using lead-through function to move the single-arm Yumi robot. And easy programming of robot for non-specialists. So for people who don't know robot coding language, there should be a graphical programming interface for them to get quickly started, and it's easier to handle for operators. Now, productivity is another very important point because the whole point of automation is to improve productivity and quality. So typically we want as high speed as possible while maintaining safety, and there are different ways of achieving this. High precision for assembly tasks sometimes is needed. It should be easy to integrate into existing production lines. For example, very typically collaborative robots are used where human workers used to work before. So they should be able to fit in there without redesigning the whole production line, and make automation of smaller production batches more cost effective. Now, lastly, we have flexibility, which is very important that many customers look for. So typically collaborative robots are smaller, lighter weight with smaller footprints, and there is less peripheral equipment involved. For example, what we're talking about today with integrated vision. So you can either have external vision that's mounted, or you can even use integrated vision into the gripper of, for example, Yumi. And this way you don't need to have an external setup with vision, etc., or other devices. Maybe you can even locate objects without fixtures and large feeders. So that's where the flexibility comes from. Now, next, let's look at ABB's Yumi collaborative robot and why it is unique. So ABB's Yumi was designed to work alongside human workers. So it has human-like arm reach and speed. It has a lightweight and compact with integrated controller inside the body of the dual-arm Yumi. For the single-arm Yumi, we do have an external controller, but then the base of the robot is very small, and the whole robot weighs less than 10 kilos, which makes it very flexible when it comes to installation. Now, Yumi has 7 axes per arm, which enable it to fit into small space and also reorient itself in very tight space. And what's unique is that we deliver it with a smart gripper that has integrated servo fingers with vision and with vacuum. So you have 2 ways of picking up objects, with a servo or with vacuum, and you can use the integrated vision for applications, which Katya will introduce later. So next, let's look at a video showing how Yumi works in production. So this is at a customer of ours called Seng in Sweden. So they have put in Yumi in a working station that used to be manned by an operator. And this was a very ergonomically challenging task. And actually a lot of vision is used in this application. So you can see the flashes. One comes from the flex feeder that is feeding the parts. So it's difficult to see here, but you can actually find this video on YouTube, ABB Robotics YouTube channel, and you can see more details on all the tasks that Yumi is doing. But basically, using Yumi, this company was able to relieve operators from an ergonomically challenging task, and at the same time improve productivity. So let's look at the next slide, where I think we're showing how even large robots from ABB can work safely and collaboratively with humans. So as I mentioned earlier, there are different ways of achieving fenceless collaboration between a robot and a human. You can have a power force limiting robot, a robot that's designed to have limited power and force when there's a collision between human and robot, such as Yumi. But sometimes you need to have higher payload or higher reach. You need the power of industrial robots, but you can actually still install them without physical fencing. So here are 2 examples. And again, they're both available on ABB's website. You can either search for ABB collaborative robots to get directly to our collaborative robot website, or simply go to ABB Robotics on YouTube. So on the left, you can see large industrial robots. This is our own robot factory, actually. And if you look closely, there is a yellow laser scanner in the corner that is supervising this location of the human versus robot, so that when the human is working like this on the robot, then the robot will not move. When the human leaves this cooperation zone, then the robot can resume working. And on the right, you can see some smaller robots working also without physical fencing. And on the roof, you can see the yellow laser scanner, which is preventing dangerous collision between human and robot. So depending on your application need, actually you can have human-robot collaboration with industrial robots as well as smaller force-limited robots such as Yumi. So next, please. And lastly, last slide from me before Katya takes over is, if you're interested, you can find more information from our online forums. So we offer free online tutorials for both single arm Yumi, dual arm Yumi, also Robot Studio, which you can find on ABB's webpage. Just look for ABB Robotics Academy tutorials. And we also have lots of videos on YouTube, which can inspire you for different applications that robots and cobots are used in. And lastly, we have a dedicated collaborative robot webpage and also an online application builder for single arm Yumi. So if you're interested now after this webinar to get started, this online application builder will give you everything you need step by step, and you can download lots of templates, animations, etc., or simulations, so you can see your first collaborative robot application. All right, that's all from my side. Now I'm going to hand over to Katya to explain how to work with vision.
Thanks, Andy. Can you hear me?
Yes, loud and clear.
Very good, thanks. Yes, a warm welcome also from my side. To make it short, yes, I'm the same person you have seen on the pictures and in the last webinar. I haven't lost a bet, and I really like the new haircut. How do you like it? Okay, I'm not here to tell you to color your hair, but the question is, would a robot also recognize the new hair color? Very often, I see a lot of great expectation for a robot. And seeing the robot as a coworker, the natural thing is to tell the robot what to do and just teach him the task by telling. Some people very often forget that the robot has no eyes. And as you've heard from Andy before, yes, Yumi has a camera in his hand, in the smart gripper. He could use it. Yes, of course, he can use it to pick the object. Another question, if he's moving the left arm in this picture, will he touch the stack of the cubes with his elbow? So the question is, he has no eyes. How does he know where to move his arm? Yes, you can solve a lot of things with vision, but as a good robot teacher, I want to make the vision task easier for the robot. I want to make it reliable. And in this webinar, you learn why and how. Here you see how the camera looks like also in the gripper. So it's really in the hand. First, I will tell you something about vision as a sensor, why we use these external cameras. Then I will show you an easy example. I will tell you more about the integrated vision of ABB. I will show you the most important challenges we face with vision. And at the very end, you will get some more inspiration. I will show you more advanced examples, easy tasks, but also more special ones. If you are searching for a step-by-step manual how to use a hand camera, there are really good manuals from ABB. Search for integrated vision, and this is not part of this webinar. My first question to you, have you ever used a robot? And on your screen, you should see the polling now. If not, click on the bar and look for polling, and it would be really nice if you would answer this. As said, we have lots of vision sensors you can add to the robot. And on the left side, we see, for example, a bin picking solution. There are different suppliers who provide this. The most important question I would ask whenever people talk about bin picking and 3D vision is, can you pick the last part out of the box? And for example, there are solutions. On the top, you see basically the one arm of the Yumi has just something to shift parts in the box, and the second hand is there to grab the parts. But you can also have things to read, for example, codes. If you have the very special system, you can connect the robot like we see it in the middle. You can use special color cameras you can see on the top right, or you can use very different 2D cameras, usually for picking parts or inspection. We also have seen that there are a lot of tasks around using vision systems, but the most important question to you, have you ever heard the answer, this is too expensive, this is not reliable, this needs an expert to set it up? Yes, most vision systems are still challenging. They will get easy in the future, but I will show you what is very useful for industry today and why. On the left side, we see one example. Here, the single-arm Yumi is picking toothpaste, putting it on a scale, and then he will use his integrated hand camera just to read the value of the scale. And of course, this is a feasibility, but as you can see on the right, this is a real customer case. So we have Yumi doing with the left arm, putting a part into a machine, and then with the right hand, he's basically operating the panel and reading the final result values also with a hand camera. This was very useful for this customer because he says, this is a place for a human being and I don't want to change a lot. So it's a really easy interface. Let's look at some more examples. With the integrated hand camera, you can, of course, pick objects, but you can also do easily some more inspections. So what do we see here? We see, for example, that you can measure the size, or you can check if the feature is there. You can read numbers, codes, and of course, find the location of the part. On the right side, you see, for example, a Yumi with two hand cameras picking from a conveyor belt on the left and the right side. So location is definitely a very common thing to do with a robot. If we don't have the integrated hand camera, but we have, for example, an external camera, like we see it on the left, the Yumi is working, but especially for cycle time reasons, you want to make it faster and you directly want to tell the location to the robot without staying on top to make a picture. Then you can use cameras on top of the feeders, but you need to tell the robot where this information or how this information is connected. You get the information from the vision system, is at location 5.2. But the question is, where is location 5.2? Where is the camera located in comparison to the robot? So the way how we do it usually is that we just mount a specific tool on the robot, and then we move it along the camera area, along the checkerboard. We take a picture with the camera to look at this checkerboard and do a very easy calibration. All these things you can do in Robot Studio. So Robot Studio is our tool to program robots, to simulate virtual robots. And here you can see that the vision picture in the middle is also included. So you can see the real vision picture, or you can also simulate the camera. So you basically can start right away by using Robot Studio, using the camera, the virtual camera on your computer. It's working in the very same way for the real robot. So if you have a real robot and the real camera connected, you will see it exactly like this. And you also have the interface on the Flex panel. So later in production, if you just want to see the results, you can also see them directly on the Flex panel. Let's have a look at how we teach a new task now. So here, for example, you see the robot is searching for the bee. How do I set this up? We choose Add Part Location tool, a PatMax tool. We just put it on top of the feature we want to search. Say OK, and that's it. So then we can see directly he has found the result. And now we still need to bring this information to the robot. Some more information here. You can also change a lot of settings very easily. So here, for example, the question is, why do I find just one bee? There are different tools. You can also search for more at the same time. And you can also change more settings, like you see the rotation tolerance on the bottom left. You can limit this, and this is something very useful, for example, for a robot, because sometimes you don't want to have the robot turning the whole cycle, but you just want to grip it in certain rotations. And to give this result to the robot, there's a special window called Output to Rapid. And once you click on it, you will see here your results from the patterns or from the tools you inserted. And you can link them to one block, which you will give as a result to the robot. Okay, it looks nice. It's easy to set up this vision job, how we call it. But how do I get the information from the robot now? And the good news here is integrated vision has as part this integration in Robot Studio, but integrated vision is also prepared functions for the robot. So these are the available functions, and the most important ones for you probably are get the result. So CamGet result gives you the result of your vision job. Or maybe you should load your task, your vision job before, and request an image, because otherwise you can probably not get a good result. And all these functions are working with the integrated camera, but also with a lot of Cognex Insight cameras. So a lot of different cameras are supported here. You can buy integrated vision from ABB. You can buy it as a hand camera for Yumi, but also for the other robots with external cameras. One hint for the specialists. Behind, we use a symbolic text of the vision job. So that means that even if you change your vision job, you modify it, you will always get the right result. So you're not just looking at one point of the vision job, and if the vision job changed, it's the wrong result. You will always get the most important one, the right result. As said, it's easy. So we have a lot of location tools, and we also have inspection tools prepared in Robot Studio. If you want to do more advanced stuff, and really advanced stuff, I will show you easy examples later, and you can already do a lot with easy examples. Nevertheless, you have even the spreadsheet view of Cognex integrated in Robot Studio. You can change between this view and the easy view. Very often I got the question, how precise is the vision? I would ask a little bit different question here. So what do you want to detect? And let's assume we have the Yumi hand camera and we want to detect the 8. If we go, for example, very close, then we just see a smaller area, but we have a lot of pixels to show this feature, so the 8 is looking very good. If we are, for example, far away with a hand camera, we have a broader field of view, but we have less pixels for recognizing the 8. So then it would look like the pixel 8 you see in the gray. What this tells us that we have a lot of influences on the final precision for your application. So it depends on the resolution of the camera, on the focal length, on the working distance, and the resulting field of view. One example for the Yumi hand camera, we have 1.3 megapixels, a focus length of 6.2 millimeters. This is fixed, first of all, but then we can play with the working distance. So let's assume we are 150 millimeter away. And then the question is, I get the field of view. And if I calculate this together, then I basically have close to 8 pixels per millimeter. That means I have 8 pixel dots to recognize a feature. And just something rough to keep in mind, usually I would recommend to have at least 4 pixels to recognize one thing you want to recognize, one feature. And that means basically in our case where we have 8 pixels per millimeter, we have 4 pixels for half a millimeter. So features of half a millimeter size in a working distance of 150 millimeter distance should be possible. But there are more influences. So if we discuss how precise I need to have it in my application, then we also need to think about the robot precision, the stable desk. Very often we have a moving desk and the camera on top, and if everything is moving, I cannot get a good vision picture. The gripper design, so for example, if I grip a part and it will automatically center in my fingers, then maybe I need to have less accuracy by getting the information where the part is. One thing here, especially if you compare different vision systems, if you read that the minimum size is, let's say, 1 centimeter, then the question is, how do we want to pick smaller parts? How precise is your application? And I have 2 examples with Yumi and the hand camera. So on the left, you can see Yumi picking very small parts from the feeder. And on the right side, you can see an electronic assembly. So here again, we pick these very small parts from the feeder, and we need to insert it in the PCB board. So here you really need to precise to put it in the board, because I've seen solutions where you scratch around on the board, but that's usually not what we want. We want to pick it, place it in the hole to not destroy the PCB board. One more important thing, lighting. Lighting is very important for a reliable application. The easiest thing is you have a feeder, for example, which has an integrated background light. We have seen some customers even modifying the Yumi hand and adding some light here. Or here, for example, for the Rubik's Cube demo, we also have the light on top. Why is light so important? Light is important to get a good picture, because just if you have a good picture, then you can really recognize your features. Here, we want to recognize the euro coin. If we have background light, we get one black circle, which is very nice to grip this coin. But if we want to recognize something on top, then it's basically not possible with this picture on the left with the background light. You see also here different solutions, like if you have a diffuse dome, so basically light is coming from all around on top, you already see more details. Very common is that we have dark field, so basically lights coming from the sides and giving the picture to the camera. Sometimes we really need to get light from on top to the object. And there are great solutions like having a dome where you have a semi-transparent mirror and basically light is coming from the side, going down straight to the object, and then you can have the perfect picture directly, or the reflection also going directly to the camera. If you don't have lighting, or if you don't have good lighting, then you get pictures like you can see on the right. On metal parts, you have reflection. And for example, if you want to find these little dots, it's easy on top of the black background, but on the reflection part, it's hard to recognize it. Here are some more examples why lighting is important. You always see on the left the bad lighting, and on the right the real good lighting. And for example, if you look at the bottom left and you want to read this text, on the left picture it's not possible to read any text. On the right picture, it's very easy. Also really think about good lighting is not about I want to see everything, but it's really about I want to see my features. If we see this part on the bottom right, if I just want to detect if the pins in the edges are there, then maybe the left picture is better because I clearly see the hole. But if I want to detect some of the cooling fins, then I'm not at all able to do it on the left picture. So that's why having a good picture is very important before you start recognizing your features. And also keep in mind, sometimes you have the sun. So if you have a window next to your robot, then it's even more important to have good lighting. Not needed in every case. You have the flash also coming from the camera. Sometimes it's enough with the Yumi hand camera, but think about it. If you have a friend doing photography, you will already know this. It's the same for the robot vision. There are a lot of additional features. You can have a lot of different lenses. You can have filters on top. You can have a lot of different lights. And you can have also different cameras. So here it's really figuring out your task and first look for easy tasks or really figure out what you need for your specific challenge. I thought I will also show you some more advanced tasks, some more examples. Very common is that we want to pick things from a feeder, but it's not enough usually to pick your part, to detect your part. Very often we also need to check if the area around the part is free to go down with a finger and pick it. One workaround is just to use a suction cup, because then you don't need to have the space around. So picking with a suction cup is usually easier. But if you want to grip parts from a feeder, then also make sure that you have the area around the part free. Then a lot of people are asking me, can you read codes and text? So as said before, yes, it's possible. And now let's have a look how easy it is. So here we see, for example, we want to read this text on top, and we also want to read the QR code. And everything you need is you need to select the tool you can see on the right. So we have one tool for reading an ID code, in this case, the QR code. You have one tool to read the text. And then I even added another tool to say, check if they match. So I want to know in this case if the one text is matching the text of the QR code. So it's just 3 tools, and all I want to give to the robot in this case is I just want to get him the result, yes, it matches. Because the question here is also, and this is something for you to keep in mind, what do you want to give as an information to the robot? So when is the robot maybe doing a different task then? So for example, here, if we see a match, yes, then it's a good part and we can go on. Maybe if this does not match, then maybe the robot needs to grab the part and put it to another place. Sometimes we also get the question, I have a very specific custom font. Can you also detect it? Yes, that's also possible. So you can train, and it's very often also recommended to train your own custom font really with your picture. And then you can also detect your specific font. Another easy example is if you have an O-ring, for example, and if you want to check if your O-ring is okay or if the O-ring has any beads, then there's also just one tool. So just insert the tool for detecting the bead, select the area where the bead is located, and you will get the result if you have a defect or not. And you can even get the information how many defects. Here again the question, what do you want to give the robot as a result? Probably just it's an okay or not okay part. Sometimes you also want to store some more data. So for example, you want to store the first part today had a defect. And also this is possible in the robot. Sometimes you also want to measure something or you just want to check. And here I really want to distinguish. So the easiest thing is just to check if the distance is correct. Why? What do you see in this picture? We detect a pattern 1 and we detect a pattern 2. And we measure the distance between the 2 patterns. And if your camera is not calibrated, so basically if you don't do any calibration, you just move the hand, for example, or use the external camera, you can already check if the distance is always the same, because the camera knows how many pixels are between your 2 features. So that's the easiest way, just to check if the distance is in a specific range. If not, you will get the information to the robot, and the robot can decide what to, or you teach the robot what to do if the distance is not in the range you expected. Also possible, here for example, we want to check this channel in the part, and if the edge is straight or if there are some kind of errors, some wrong manufacturing. So here again, it's one important tool here. It's the edge width tool. So you just insert it, you mark the area where you want to check it, and you will get the result. Here in this case, in the range you selected, 2 defects. In the video Andy showed us, we have also seen something else. You have one hand and detecting the part with the other hand. This is also possible. You can move the hand depending on the result. So for example, if you have an area and you want to check if a part is located here, just check it. If there's no part, you can also go to another area. Or what we have seen as a solution before, you grip the part and you're not sure if the rotation is correct. So you can check it with the camera and then move the robot arm to your aim position and rotate it so that you always place it in the correct position. Also, some logic can be done in the vision job or in the robot. So for example, if you want to do a two-step vision job, so say first inspect if it's a correct part, and then check if the QR code is correct, you can do it in one step in the vision job. You can do it in 2 steps, the logic in the vision job. Or you can give this task from the robot. So say, first I want to check it. Maybe then I also want to move the hand. And then I want to check something else in the same job. This is also really easily possible. You can change values in the vision job from the robot. So there's a prepared function called can get result or can set value and can get value. So you can get the value of the vision job and you can set the value of the vision job. Before I said that just checking if the distance is correct, that's very easy. But sometimes we really want to measure something. So for example, on the left picture, if we want to measure really the distance and we want to get a result in millimeter, then it's important that you first calibrate your camera. So basically, for example, take a picture with the camera of the checkerboard and your camera get the information, one part of this checkerboard is 1 centimeter and I see it with this amount of pixels. So then I also know if I see, for example, 6 pixels, I know how many millimeter these are in the real world. So yes, it's also possible really to measure things with the camera. Also, keep in mind, you need to have enough pixels really to detect the feature, because if you cannot see it, then you can also not measure it. Other possible examples. So you can also combine different tasks. So here it's, for example, a milk can, and you can check if the cap is present. So if the cap is mounted or is assembled to the milk can, this is what we see on the left. So on the top picture, the cap is there. On the bottom picture, it's missing. Or you can just detect if a label is added to the milk can. So really this inspection task can very often be included in existing tasks. So if you have a robot, you have the robot doing the pick and place, but you want to add, for example, some more value, then just add a vision task, add an inspection task, because then you can really make sure that your product, maybe you need to prove that the label is already there. Maybe you need to prove that the disk is incorrect. The robot can take this task as well very easily. Another more advanced thing is that you can check, for example, for this package, if you see the front or the back side. And if you see the front side, that's fine. Maybe you turn it around with the robot. But if you see the back side, you want to read the QR code. So even in the vision job, you can decide, if I see this, I can fulfill one task. If I see something else, I can do another task. So lots of possibilities here as well. For reading text, there's also one recommendation. So there are filters included. And if you put a filter on top, for example, here to increase the contrast, it's often a lot easier to read some text. So here, for example, we have the binary filter on top, and then it's a lot easier to put one more vision detection on top. Also possible here to check if the middle part is really assembled in concentricity with the other parts around. So you can find circles and you can check if they are really aligned, if they are really concentric. I also said, or you've seen the Rubik Cube demo. This is not possible with the integrated hand camera because it's just a black and white camera. But from Cognex, you have color cameras, and you can use the inside cameras from Cognex also with our integrated vision. So here you can really select your color, you can train your color, so lots of possibilities. Also, a very much advanced feature is with the new Cognex camera. You have, for example, here this very special lighting on top. You can switch on different lights here, and then you can make different pictures and combine it to one. And what you can see in the left picture is that even for our eyes, it's really hard to read basically the relief under the text. But if you do these pictures with different lighting and combine them to one, then you can see basically just a relief, and even the black text, which is annoying on top, is deleted. And in the right picture, you can really read the date 1/4 here, for example. So there are lots of possibilities. If you're interested in using more advanced features in the back, I would recommend to search also for spreadsheet and Cognex. You can even include your own scripts there. So from coming, the very easy task, just doing one rectangle, detect the pattern, get the information to the robot, until doing a lot of different inspection, location tasks. There are a lot of possibilities. A short wrap up. So we have seen that vision is basically an additional sensor for the robot, and it can have a lot of different sensors connected. You can do very easy but also advanced applications, and the easiest way is probably really to use the integrated hand camera because everything is there. You have a ready-to-use package available. And now it's time for your questions and our answers.
All right, thank you both for the presentation part. So I'll let you guys go to it. It's a few questions in the Q&A panel. And also for our participants, if you have questions now for the team, please use the Q&A panel and ask questions. And you can also use the chat to ask questions if you want to. So Andy, the first question, who are the ones that must learn to control this robot?
Well, this depends on your company, but it can be any technician. It could be a technician that is currently working with automation equipment. Yes.
Yep, perfect. So do you need some kind of training before putting your hand in the robot?
Not sure what he means hand in the robot or on the robot, but to put your hand on the robot. So you must, of course, always read the safety precautions, right? Just like any equipment, wrong handling can cause, you can even drop it on your foot, but just please read the safety disclaimer and go our online tutorial. So when you receive a robot, there will be, for Yumi, for example, we have online tutorials, so it goes through it step by step. It will explain to you how to set up the robot and get it moving the first time. So you can do this online. You can, of course, also go to ABB Academy for an in-person training as well. Just contact ABB office in your respective region.
Great, thank you. And how easy is it to use input from external vision processing or image video analysis rather than the output of the internal vision job within the wizard?
Leave that to Katja.
Okay, the question is here also for other cameras, right?
Yeah, I think the question was if you'd not want to use the internal vision one for external cameras, how easy that would be.
Okay, then maybe a very important answer here, because I've seen different other questions here as well. So the UMI, or the controller at the end, provides a lot of possibilities to connect. So coming from TCP IP to Profinet to a lot of possibilities. So if you have an external system and you want to connect it to the robot, at the end you need to exchange this information. So the recommendation is here that you have basically the part doing this kind of vision task really done on your external device, can be computer, can be on the camera, can be wherever, and then basically communicate the information to the robot. And as said, there are different ways really just to communicate basically the text information. If you really want to give it as an information where to move the arm, especially for universities, we see this a lot. Then there's also called the function called EGM. So just search for it, then you can directly give information to the robot arm, basically.
Perfect, thank you. So another one about integrated vision systems. Are you working on using it for to perform calibration, absolute accuracy on site? So say calibration after maintenance of a robot at the customer's facility.
So we are not using integrated vision for absolute accuracy calibration. I believe the reason is that we need a much higher performance system, and it's not necessarily a vision system, it's a laser, like a laser system that we use for absolute accuracy.
Yeah, thank you. So another pretty specific question. I have a pattern matching program. I use sliding window algorithm, but it's slow. Is there a way to speed it up?
I would say if it's a specific algorithm, then it's lying on the person who created this algorithm to check it. Here, again, basically this integrated vision is very fast. If you create your own thing, then it's a question, is it really your system or is it the communication to the robot?
Another question here. One of our participants has seen our CEO presenting the new facilities in China, and that shows a collaborative robot mounted on an AGV. Pushing the boundaries of technology is the name of that. So are those yet part of your product portfolio, or when do you think we could see this in the product portfolio?
So at the moment, the AGV that's shown is not a product that we sell, but you can mount an ABB robot such as Yumi on an AGV. So there are lots of examples you can find on YouTube as well. So basically you can buy standard industrial AGVs and mount a robot on it. You just need to take care of, one is a power supply, of course, but the second is also the AC-DC power transformation. But it's completely possible already today.
Great, thank you. So is it possible to recognize depth with a 2D camera?
I would say if you have a static 2D camera, of course not. If you use the hand camera in a clever way and you move it around and you write your algorithm for this, until a certain amount, it's possible.
Yeah, thank you. You mentioned the hand camera. Is that such amount, or does the robot hold the camera in the grippers? Based on my understanding, for standard articulated manipulators, there exists no default mount, and the end effector is unknown.
Okay, so for the Yumi hand, it's really integrated. So also all the wires go through the arm. If you want to add, for example, on a bigger industrial robot, the integrated vision camera, then you have very often connectors like Ethernet on top, or also cables for power supply, and you can usually connect it to the upper arm.
Perfect, thank you. And I think we touched upon this, if it's possible to use ABB Vision with other cameras, such as Intel RealSense.
Yeah, so you just need to have the interface and then it's possible. But not in integrated vision.
So are the packages, the functions for Vision included in Robot Studio without additional licenses?
If you buy a dual arm Yumi, it's included. If you buy the single arm Yumi with a hand camera, it's also included. If you buy an industrial robot, you need to select the option integrated vision.
Great, thank you. So is it possible to have a document where it's explained how to access the different patterns, parameters, instructions?
Yeah, so here it's or you can look for the instructions in the robotware and search for integrated vision, and then you will find all this.
Perfect, thank you. When the robot asks the gripper to load a program for the first time, load cam job, is it usually that it takes a while? Is there any way to do it faster?
Yeah, for the first loading, the only way to make it really faster is to get either a faster camera or to make your vision job smaller. But as said here, it's usually just a loading. What we see is that the recommendation is if you want or need to change your job several times, then the question is, can you, instead of changing the job and every time loading it, include the different tasks in one job? That's how I showed that you can also have different tasks on one job, also not executed all at the same time. And this makes it, the loading maybe even longer, but then you just need to load it one time and you can keep it for different tasks. So, and this, then you don't have any loading time in between.
Great, thank you. And let's see, how accurate is the calibration of the camera coordinate system with respect to the base coordinate system with a component or with a chessboard? Is it in millimeters or micrometers, or what are we talking here?
As I showed, so this is basically depending on the resolution of your camera. It's yeah, depending on the distance you have, and it's also depending on how accurate your robot is. So all this together then brings you this information. But it's a rough idea. It's in sub-millimeters.
And I had a question come in the chat as well. Is there a tutorial for integrated vision from start to end? Do we have something like this, or is it something that we can create?
Yeah, I would say there are good manuals. So if you search for the manual for integrated vision, it's really good. If you want to have a course, then contact your local training center because they usually offer training courses for integrated vision.
Great, thank you. And is it possible to have two hand cameras?
Yes, so you can have one camera in each hand. So not two cameras in one hand, but in each hand you can have a camera. And you can also connect it, so you can easily have two cameras on the side plus two hand cameras. So you can have four cameras together. That's not the problem.
Perfect, thank you. There's also a question if you can comment on any industries or fields where this technology is really being used to improve it.
Yeah, once more, which technology? Using the
So this is a question that came to me privately in the host chat. So they're asking about if we see any specific areas where this vision is being used, like in specific industries, or where can it really be used to improve processes?
Okay, I would say in general, this detection of parts and the inspection we can see across all industries. Where I see development in the future is definitely that the vision systems will get cheaper, they will get better functionality. But here the question is, when is it cheap and reliable enough to use it in industry?
Thank you. We have a question from a Yumi programmer in a mechanical factory. When you change the reading height of the item, is it necessary to change the focus of the Yumi's integrated camera?
Yes, so if you're too far away, you need to adjust the focus. So you have this little wheel on the focus and you can turn it and then you can adjust it, yeah.
So I think as a camera questioner, is the 1.3 MP the best, or are there options for a better?
For the integrated camera at the moment, it is one option. If you need higher resolution, then you can also use the external cameras, also with the Yumi.
Great, thank you. So I think that brings us to the end. Just let me double check the Q&A here and the chat. There is one last one here. Can integrated vision process video data?
No. Just pictures.
Yeah, and can we use Python to do the computer vision and send the information to Yumi to act accordingly?
Yes, so it's definitely possible to run Python on a Raspberry Pi, on a computer, wherever, and then just communicate the information to the robot. Yes.
Perfect, thank you. So that brings us to the end of the webinar. I think we're about 2 minutes over our scheduled time. So right now, I'd just like to hand it over back to Andy for some final comments.
I thank everybody for joining the webinar. I hope the information was useful. Judging from the questions, I think it was very useful for many of you. So if you have more questions, please get in touch with us. There is an email address which is posted on our Collab2Robot website. So please go to our Collab2Robot website. And please sign up for our future webinars as well. We will talk about how to build concrete applications. All right, thank you, everyone.
Thank you all.
Thanks a lot.
Bye-bye.
Bye-bye.